Hi, this is Pat Hindle with Microwave Journal. Welcome to this EDICon Online Educational Day session. Our platinum sponsors are Samtec and ComSol, and our track sponsors today are Mini Circuits, CPI Electron Device Business, Altair, Keysight Technologies, and Mari Microwave. This session is 5G Advanced, moving towards 6G, given by Viet Nguyen, President of 5G Americas. Now I'd like to introduce our presenter. Viet Nguyen is the President of 5G Americas. In his executive role, he is responsible for the overall planning of organization and providing management for the integration of strategy and operations in the areas of technology, marketing, public relations, and regulatory affairs. Now I will turn the session over to Viet.
Hello and welcome to this EDICon Online 2025 technical session. I'm Viet Nguyen, President of 5G Americas. Today, we are going to explore how 5G Advanced is bridging the gap between today's 5G networks and the future of 6G. This isn't just about faster speeds, it's about enabling an entirely new generation of intelligent, immersive, and sustainable networks. To give you some context, 5G Americas has been around for about 24 years. We are the voice of wireless innovation across North America. We focus on collaboration and thought leadership and education around next generation mobile technologies, from 5G and 5G Advanced to the road ahead towards 6G. We are made up of leading wireless telecom operators, equipment manufacturers, and service providers throughout the region. You can see some really great leading wireless companies here on this screen. So let's stop for a moment and take a look at the big picture of how we've got here. Over the last 4 decades, cellular technologies has evolved from analog voice to a world of connected devices, immersive video, and intelligent automation. And today, 5G is widely deployed. Next, we'll have 5G Advanced, which enhances network performance and intelligence. And beyond that lies 6G, which is going to be a truly transformational leap. If you look at the timeline here, you can actually see 1979 with analog voice to 91 to texting. Really, the era of unified specifications began around that 2001 timeframe as 3G sort of got off the ground. There really became a need to be able to bring all of these disparate technologies together under a single set of specifications that would ultimately become a global standard. That is something that we call 5G today, and are going to lead us into sort of 6G down the line in 2030. As we get in from 2025 to 2030, 5G Advanced is going to act as it's going to be a stepping stone, an evolution, where enhanced features and AI integration are going to allow for next level performance. And then as we get into 6G in that 2030 timeframe, we're really going to be talking about a fully immersive and intelligent network that is really going to be transforming connectivity. I'll get into that in a second. But let's take a look at where we are today. Today, there is over 2.25 billion, that's with a B, 5G connections across the world. In the last year alone, we added 667 million new global connections. And as we look ahead, Omdia data suggests that global 5G connections will reach 8.34 billion or 8.35 billion by the year 2029. As a share of wireless cellular technologies, 5G is expected to be about 59% of the global access networks by the year 2029. Additionally, the Internet of Things, IoT, saw unprecedented expansion in 2024 by adding 438 million new connections in 2024, bringing that global total up to 3.6 billion IoT connections. And so as we think about 5G and turning into 5G Advanced and turning into 6G, we are seeing momentum here today as there are a handful of some operators around the world who have already announced their 5G Advanced networks, or the imminent announcement for the 5G Advanced networks that they are going to be building out throughout 2025. We're anticipating to see several more networks coming online with 5G Advanced networks this year in 2025 as the foundations of standalone 5G allow for these improvements to occur. And as we move forward through 2025 beyond, we're going to see about a 30% compounded annual growth rate in 5G connections over the next few years, which is astonishing, and it's actually about 4 times faster than what we've seen between that same period of time when 4G LTE got off the ground. So what does this sort of look like? As I mentioned a little bit earlier about 3GPP, these set of specifications, 3GPP is an organization that's really tasked towards sort of building together a set of technical specs that are based upon requirements created by the International Telecommunications Union. The ITU is a UN body that sets standards, and these are sort of minimum requirements for what wireless networks need to maintain to be able to achieve within the time frame. And so if you look at where 5G began back in 2017, that really started with release 15 with, and you see here the acronyms, enhanced mobile broadband, basic ultra reliable low latency connectivity. That really started the work for the specifications really began in that time frame leading up to the end of 2018 and then the 2019 deployment of 5G. Since we're in 2025 today, we've already seen release 18 occur, and release 19 is anticipated to occur by the end of this year, by the end of 2025. And a lot of these advancements, a lot of the technology advancements that we're going to see in 5G Advanced are going to be implemented beginning this year and as we go into the next few years. With the work going through release 21, sort of release 21 is really going to be identified as that first release that's going to identify what those 6G, sort of those basic requirements are going to be. And that is really going to be work that's going to take place in 2027 to 2028. And so we're going to start to see 6G networks really aiming towards that 2029 to 2030 timeframe really get rolled out there. So that's all well and good. You can kind of see the timeline there, but what are these advancements? What are some of the things that are going to be significant as we prepare for getting the requirements of IMT 2030 off the ground? Okay, so let's take a look at this this slide. It's a pretty complex slide. There's a lot of stuff that's going on here, but I'm going to take you through some of the technologies that are going to be really significant in 5G Advanced. As I mentioned a little bit earlier, enhanced mobile broadband is really a lot about the speed improvements that we have been seeing in 5G and are continuing to advance on with the 5G Advanced. There's a lot of higher spectral efficiency through improved multiple in, multiple out sort of antenna operations. It's going to be a lot of work done with AI enhanced beamforming and optimization of the radios that happen in the radio access networks. Additionally, we're going to see a lot of improvement happening in that uplink boost. In previous generations of cellular technologies, we saw a lot of emphasis on the downlink, on the download side of the house, as people were downloading a lot of things, on the internet. But as we move into the age of AI, we move into the age of edge networks. There's a lot of data that's really coming in from the edge that needs to get to that data center to be processed. And so that uplink boost is incredibly important within the radios to be able to bring that data across those networks. And of course, we're also going to see really a lot of extension into the 7 gigahertz and higher spectrum bands, and I'll get into that spectrum a little bit later. But 5G Advanced is laying down the groundwork for 6G to take advantage of these new spectrum bands, these higher spectrum bands that have much greater capacity for these new networks that are coming on board in a few years. As we look also, one of the most significant advancements that we've seen beginning in 5G Advanced is really an AI and machine learning native architecture. This is really the first time where you're seeing wireless networks have this level of integration. Now, our wireless networks have worked with AI and ML for many years. And there's been a lot of work done with self-optimizing networks and a lot of enhancements that are going to be going on. But this is really the time where a lot of this stuff gets fully baked in to the actual specifications and allow for AI and ML native processes like scheduling, like channel estimation and beam management, load balancing, to be able to optimize these networks at a very low level. And so what does that lead to, right? So it leads to intelligent network automation. So what that really is going to allow the networks to do is really understand what is going to be needed by the customer, what is really going to be needed by that service level agreement, and to provide the resources, the network resources, whether it means spectrum resources, whether it means compute, whether it means storage, or additional sort of presence and coverage by those radios, based upon what those customer needs are identified in that service level agreement. And so that's something called network slicing. And you're going to see definitely more and more opportunities for network slicing to occur as networks get more sophisticated, as customer needs get more sophisticated as well. And so there's going to be a lot of sort of intelligent handovers and mobility improvements that we're going to see over the next few years in 5G Advanced. Additionally, one of the other areas that's really significant is reduced latency and improved reliability. The time-sensitive networking that's being built into 5G Advanced networks is incredibly important, and it's really this concept of deterministic networking for industrial applications, right? So this is the idea where you understand what you're trying to accomplish at the end, and so the network sort of gets modified to be able to accomplish what it is that the end user wants to accomplish. And that time-sensitive networking is incredibly important for things such as precision manufacturing, where you really need to get the timing of the data correctly, or else things sort of fall apart. Another area that's really significant is low latency with RedCap. RedCap, or it's actually a shorthand for reduced capability devices, is really about providing the right level of spectrum, providing the right level of power and complexity for the device that you're going to be using. And that's really significant for things such as like wearables or sensors, where, for instance, they might not utilize a lot of data. And so that might just require a little sip of data from time to time to be able to update location or update a change in the status. And so these RedCap devices are very optimized for that type of operation, and there's a lot of support that's going into that within these 5G Advanced releases leading into 6G. Of course, one of the other areas that's really significant is energy efficiency and sustainability. These networks need to be energy saving, and so that's where things like AI and ML can actually work with energy efficiency, where it'll allow for the networks to understand when it needs to turn off specific parts of the network and the cells to switch off when they're not in use. And again, RedCap, very important to allow for wake up to occur for some of these devices, which might be in sleep mode until the network says, hey, wake up, you need to update your status or give us a status. And that kind of activity helps to really extend battery life. So a lot of these new things will lead into sort of expanded use cases and verticals. We saw a lot of activity that happened really early on in that 5G cycle for extended reality, and there's additionally a lot more that's coming down the pike in terms of 5G Advanced. There's a lot of enhanced throughput and latency improvements for augmented and virtual reality and metaverse applications. There's a lot of improvements that are going to be happening in the industrial IoT and smart factories settings, that time critical communications and that ultra reliable performance. And if you can, this is particularly important for the United States, right, where we're seeing a lot of the reshoring of manufacturing happening. And as that reshoring occurs, there's going to be a lot of effort that's being put into private 5G networks in particular, in these manufacturing factories, and there's going to be a lot of requirements that are going to be needed for getting that wireless data to the devices or to the automation that's going to be happening in those factories at a very, very precise degree. Additionally, we're going to see vehicular and drone connectivity happening as a part of 5G-Advanced with more precise location, a lot of critical use for public safety applications. And that's really going to be helped from a coverage standpoint by having the non-terrestrial network. I mean, what I mean by that is the satellite support. There's a lot of integration that's happening between satellite operators with our wireless land-based cellular operators that will allow for that satellite coverage when you're not in that particular cellular area. And so that kind of sustained coverage and connectivity is going to be important as we move forward in the next few years. Additionally, positioning and sensing. In 5G-Advanced, we're going to see centimeter level positioning accuracy. Again, very important for factory automation, for autonomous driving and logistics. And at the same time, it's really important to have integrated sensing and communications happening. As you start to densify those radios, the transceivers on those radios, that it will, and the sophistication of those radios will allow it to act both as a sensor and a communications tool, which is really an early step towards 6G. As these surfaces begin to get more and more dense in terms of their transceivers and that radio coverage, they will start to act both, again, as a sensor and a communications tool, and allow for sort of this precise, rapid connectivity to occur. And of course, one of the most important things for any network is the enhanced security and trust. You know, we're starting to move into the quantum computing age, and there's a lot of work that's being done right now to prepare networks for these future challenges where these quantum computers with a massive amount of compute power are gonna come to the table. And so the more that's done today in terms of being able to build zero trust architecture, allowing for stronger authentication and authorization, that's really important as we prepare for this 2030 6G timeframe. So let's look at this vision for 6G, right? So you know, we've talked about a lot of the technological sort of stepping stones. Where are we headed? So for 6G, the vision really is about this seamless fusion of this digital space and the physical space and human world sort of colliding together. And we know that you know, with all of the robotics and all the automation that's going to be happening in the next few years, they're going to need to have a digital sense of what the world is, and they're going to need to model that world, and they're going to need to update that model very, very continuously. And so there needs to be this fabric that's sort of interwoven between the two, and that's where that wireless connectivity becomes very, very important to be able for these devices, these robots, these you know, all the autonomous vehicles to be able to operate within a physical space. That's going to require intelligent networks. Obviously, there's going to need to be autonomous decision making at every network layer. This isn't just, you know, your standard, hey, you know, AI and ML happening at this particular layer. It's really going to need to happen across the layers, from that app layer all the way down to the various levels of the different network layers, to ensure that data gets utilized and routed most appropriately for these networks to be able to deliver what they are asked to deliver on when it comes to particularly AI processes, right? And of course, I talked a little bit earlier about sort of this global coverage, right? With integrating the satellite and networks to the terrestrial networks, the goal is really to eliminate those connectivity gaps and to be able to allow for again this fabric of connectivity to happen. That's really one of the visions for 6G as we go forward. And so, as I mentioned a little bit earlier, right, the ITU, the International Telecommunication Union, is really, that's a UN body, right? And so this UN body creates these requirements that sort of set the standards for what wireless cellular needs to operate at. And those sets of that framework of requirements is called IMT 2030. And we had one in IMT 2020 for 5G. So the 2030 is for 6G. And so what those standards are going to be looking like are experienced user data rates of about 300 megabits per second. That's actually, if you look at it from a peak speed standpoint, it's up to a terabit per second, which is incredibly fast, right? And again, that's peak, right? So that's going to be sort of at the end of the cycle, at very, very optimal conditions, you're going to be able to get at that terabit. But for most user experience data rates, you should see improvements at about 300 plus megabits per second. And the area traffic capacity is going to be beyond about 30 megabits per second per square meter. When you look at that massive connectivity, one of the things I mentioned was that 5G actually delivered massive connectivity of up to 1 million devices per square kilometer. But as we look into the 6G space, as we look for IoT and smaller and smaller and smaller sensors, you're going to see the capability of managing up to 100 million devices per square kilometer within that framework. And that's going to be, if you start to think about things such as health sensors and things which need to be very small and discrete and not utilize a lot of power, but still need to be able to be connected, that's the kind of thing that we're talking about that 6G will deliver, right? Think about the touch sensors that might need to happen on those robotic fingertips, right? Or anything that might require, sense of touch, right? That's they might not be very, very large sensors at all, but they still need to be connected. And along with that needs to be ultra low latency. With 5G networks, we saw the capacity of being able to get down to millisecond. And when we talk about 6G, one of the things that potentially could be coming on board is getting less than a millisecond of latency. And that's incredibly important for things like extended reality, for autonomous vehicles and robotics, to be able to respond in a really 1,000th of a second, right? And so that will allow for these devices to be real time, allow them to respond to immediate changes in the environment, and really build that physical digital layer for the next generation of wireless networks. And of course, one of the things also mentioned earlier is energy efficiency. Of course, these things also need to be designed for sustainability, despite increased capabilities that they provide. So how are we going to get there? Of course, 6G is going to require additional spectrum, and we don't have enough of it today that's commercially available to get there. But what's going to happen with those 6G spectrum bands is that we are going to see some of those spectrum bands that are used by 4G LTE or even 5G today be refarmed, be repurposed for 6G use. And but that won't be enough. When you look at sort of this I guess this is chart or this illustration, you see actually this new band of the 7 to 15 gigahertz range. It's going to offer quite an additional amount of capacity. There's a certain band that's in there. It's that 7 to 8 gigahertz band. That's sort of what we refer to as the golden band. And that's going to be a really key frequency for global harmonization. The goal would be, of course, if every country on Earth were to be able to make that available, we would be able to have devices that would be able to be utilizing 6G across that band. It's important because it does provide about a 20x capacity increase compared to where that current mid-band spectrum allows for. And with the refarming of this spectrum could be done with the existing base stations, and as they get sort of retweaked for advanced beamforming and massive MIMO technologies to allow them to be able to utilize the strengths of 6G. So what needs to happen? Well, a lot of testing, a lot of standards development. There's a lot of collaborative test beds that are going on right now. IEEE's Innovation Test Bed really does a lot of work in validating new technologies, creating real world testing environments. There's a lot of industry partners contributing equipment and expertise, really working to accelerate the technology readiness. And of course, 3GPP continuing to build the technical specifications that are going to support the global IMT 2030 standards, really helping to prevent that market fragmentation This is really going to require a lot of stakeholders, a lot of operators and vendors, and a lot of folks in those vertical industries, so that we can, as operators and as network equipment manufacturers, understand the needs of these vertical industries as they themselves go through a digital transformation to their AI future. And of course, this requires a lot of consensus to occur. So, in conclusion, there's a few things that should happen, right? 5G Advanced is that foundation. It's not just an upgrade; it's a foundation for 6G's world. Please stay engaged with the standards. Please follow 3GPP's developments and participate in industry forums and join any of the collaborative efforts there. You can find a lot of this information at 5gamericas.org. It comes from these 4 white papers that we produce. We produce about a dozen of these every year, and they are chock full of great information for you if you want to find out anything about 5G, about 6G, and about where the wireless cellular industry is headed. I thank you for your time, and hope that you have a great day, and keep yourself informed. Thank you.
Thank you, Viet, for a great presentation there. Now we have time for